Welcome. In this video, we will show you the modeling of hydraulic suspension. There are 4 learning objectives. The first one, we will show you the basic working principle of hydraulic suspension. The second, we will show you what components are used in the simple vehicle hydraulic suspension model. The third, we will show you how to set parameters for hydraulic components. And finally, we will run the simulation and analyze the results, and change the diameter of orifice for sensitivity analysis. A basic hydraulic suspension system consists of hydraulic jack, orifice, accumulator, hydraulic oil, and gas. At the bottom of this slide, there are 2 schematic diagrams. The left one is the initial status of hydraulic suspension, and the right one is the steady state, which is a few seconds later after external force applied on the piston. Because of external force, the piston moves down and the hydraulic oil is squeezed by piston. As we all know, liquids are almost incompressible, so the force is equally transferred to the gas by the hydraulic oil, and the gas is compressed. This process happens at the same time. In addition, the other end of hydraulic jack is connected to the ambient. In the previous slide, we introduced the operating principle of hydraulic suspension. In this page, we will introduce some equations about this hydraulic suspension. Equation 1 is the volume change of hydraulic oil in hydraulic jack. Equation 2 is the volume change of hydraulic oil in the accumulator. Equation 3 is the volume change of gas in the accumulator. And equation 4 is the equation of state of gas. In this system, we need to make the following 3 assumptions. Number 1, regardless of cylinder leakage. Number 2, ignore the influence of gravity. Number 3, consider accumulator is adiabatic. In engineering, a vehicle suspension is one of hydraulic suspensions, so we will learn how to simulate the system of hydraulic suspension using MSIM. The picture at the bottom of this slide shows the conversion from schematic to MSIM model. Now let's begin to build vehicle suspension model by MSIM. First of all, we need to know what components are used in the simple vehicle hydraulic suspension model. There are 7 functional components with light blue background. And then place those components to the sketch area. Finally, go to the submodel mode. In this step, we should select the right submodel for all components. You can also use the Premiere submodel to select the submodels in one click. Now we will show how to set parameters for the hydraulic suspension model. If you have opened MSIM, you should enter the parameter mode of MSIM and set parameters refer to the value of table as shown below. We should notice the units of parameters. We can get the results after run the simulation. In this process, the piston starts to move and the hydraulic oil starts to flow from hydraulic jack to the accumulator, which leads the pressure of gas to increase at the same time. There are 4 curves on the right. The first curve is the force applied on the rod of piston. From the moment of 1 second, a 100 Newton force is applied to the rod. The second curve is the displacement of piston. The third curve shows the change in the hydraulic oil flow rate. And the fourth curve shows the change of gas pressure in the accumulator. In this process, the piston starts to move and the hydraulic oil starts to flow from the hydraulic jack to the accumulator, which leads the pressure of gas to increase at the same time. There are several gradually weakening peaks on the second curve, and finally the system reaches a steady state in a few seconds. Why is there a shock? There are 3 factors: the mass of the piston, the diameter of the orifice, and the pressure of the gas. They reflect inertia, resistance, compressibility respectively. In previous slide, we analyzed some results. If we want to know some parameters impact sometimes, what can we do? Maybe you can do sensitivity analysis. In this slide, we will change the diameter of orifice, set 5 diameter values in the study table. They are 1 mm, 1.5, 2, 2.5, and 3 mm, and then run the simulation. And we can get the pressure curve of inlet and outlet of orifice. We can find that the bigger diameter, the longer stable state time, and the bigger amplitude. Let's conclude. First, we introduce the basic working principle of hydraulic suspension. Secondly, it's shown how to build a model of hydraulic suspension. Then, as a final step, we analyze the simulation results and show the result of sensitivity simulations. With this, we end our lesson on hydraulic suspension. Thank you.